Hello everyone, this is Ismail and today we shall be looking at leveling methods. The channel is Boom Facts, so in case you're interested in the preceding videos, then you can subscribe to my channel and then you can be able to get enough videos about the surveying and then civil work. Just a brief introduction about leveling. Leveling is just an art of establishing the elevation of any point above or below the Earth's surface. So in case you want to know how high above or how low below the Earth's surface a point is, what we do is what we call leveling. And how to come up with these conclusions, we have methods that we use. And these methods are broken down as you can see here. Now we have the direct methods of leveling and also the indirect methods of leveling. Under direct methods of leveling, we have simple leveling, as you can see here. Then you also have differential leveling. And then for indirect methods, we have trigonometric leveling, barometric leveling, and also the stadia approach of leveling. But for today, we are going to look at these two under direct methods of leveling. So these ones will be covered later, but here we are going to talk about the direct methods of leveling. So under direct leveling, we see that this is where the elevations are determined by obtaining the measurements directly from the instrument. So we get the instrument, take observations from it, and then straight away we shall be able to get the height, the elevation of any point above or below the Earth's surface. So the results that we shall get from the instruments are going to be conclusive for this case. And like I said up there that the methods are the direct leveling methods are further broken down into two. Then you have the simple methods of leveling, and then you also have the differential leveling. So we are going to talk about these ones independently, and then we see when do we use each. Now let's start with simple leveling. Let us take this example here. If you have 2 points, let me say point 1 and then point 2, and then we want to know the difference in elevation between point 1 and then point 2. We have to make sure that for this approach here, the 2 points are supposed to be intervisible, and then they are supposed to be near each other. So we just put the instrument in the middle here, and then we put the staff at the first point, then take the observation from that point, from that staff. That measurement is that observation is going to be recorded as B. That is the back side. Later, we are going to shift this stuff here, and then we take it to point 2, and then we tilt the lever around, and then we shall be able to focus the same stuff at the new position. So what we shall obtain as our observation shall be recorded as F. Now, if we want to get the difference in elevation between point 2 and 1, we are going to get the backside B, then we subtract F, which is the forward side. So from this formula here, you can see that the difference in height, the difference in elevation, delta H, is obtained by getting B, which is the backside, then minus F, which is the forward side. By doing that, you'll be able to come up with the difference in elevation between point 1 and point 2. Remember, we are taking the direction of 1 to 2. So the difference in elevation between 1 and 2 is backside at 1, then minus forward side at 2. I talked about it that when do we use this approach? It is only applicable when these two points are close to each other and then they can clearly be seen, when there is nothing like an obstacle in the middle. Previously, we were saying that in case these 2 points are near each other and then the 2 points of interest are near each other, and then you want to know how the difference between the elevation of these 2 points, all you need to do is put the instrument in the middle of these 2 points, and then you can take your readings from the staffs placed at the first point and then the next one if they are near each other. However, if in any case we have to use more than one instrument station, that becomes differential leveling. Differential leveling is just a series of backsides and foresides carried out to connect one point to the other altogether. So in case these 2 points are one, they are very far from each other. And then also, if these 2 points are having a physical barrier between them, we shall have to establish very many instrument stations such that we can bypass the barrier and then we will finally come to the point of interest. Also, if the difference in elevation between these 2 points is very big, then you will have to opt for differential leveling. To explain this, maybe take a scenario when you have something like a hill, a steep hill like this, where you have maybe point X at the bottom here and then point Y up here. These 2 points might be close to each other, and then if you put your staff here and then the staff here and then you put your instrument somewhere here, so if you try to take the backside reading, maybe you'll be able to take it backside and then you record it. But if you try to focus the following stuff, you will not be able. The line of collimation will be directing you to the ground. So what we do, you can't use one instrument station here. So what you have to opt for is differential leveling, as we shall see. So to make it more clear here, I have this diagram here. These 2 points, point A and then point B, are the points of interest. However, one, they are far from each other, and two, they are not clearly visible. So there is no way you can put one instrument here in the middle and then you focus the stuff at A and then at B. So what we do, we first put the stuff at A, put the instrument at position 01, and then we focus the stuff at A, and then that will be our backside, and then we do our foresight at C1. Then we shift the instrument and then we take it to O2. If we take it to O2, then we observe backside and then foresight. We keep on taking backsides and foresights as we are shifting the staffs and then the instrument until we reach the final point B. So we will have the readings at A as the starting point and then B as the terminal point. By this we shall be able to connect and then establish the difference between the elevation of point A and then point B by differential leveling. Differential leveling is also, we have the methods under differential leveling, which as shown below. We have fly leveling, we have profile leveling, we have reciprocal leveling, we have check leveling, and also recite leveling. And then we are going to examine each of them closely, and then we see how each and when it is employed. With fly leveling. Fly leveling is employed in case we want to establish a temporary benchmark for our work. Let's take an example. We are going to construct a house maybe in a village, and then the benchmark is established in the town. So in order to connect the benchmark from the town and then we establish a temporary benchmark at our site, we are going to do differential leveling. We are going to do backside and foresight from the benchmark and then up to the final point where I want our temporary benchmark to be placed on the site, such that we are going to use that one as our own benchmark for the survey work that we are going to do in the construction process. So we are saying that this is adopted when the benchmark is at a distance from the point where the survey is to take place. A series of backsides and foresights are made until the point of interest is reached. So here you can see that the benchmark is at some point here, and then we are going to do the survey from our starting point is here. So the only way to connect the benchmark to our starting point here is what we do differential leveling to connect these 2 points, and that is what we call fly leveling. So fly leveling is a form of differential leveling for which purpose connecting the point or where we want to start our survey from to the benchmark. So we take measurements from the benchmark and then connect it to our point of interest where we want our temporary benchmark to be. such that we can base on it when we are doing our own survey. Because this benchmark here is very far that we cannot always use it for reference when we are making our surveys here. Just in case if it's a house we are constructing a house somewhere very far in the village, and we can't keep on referring the benchmark somewhere in the town, so we have to connect this benchmark to our temporary benchmark at the site, where we shall be able to refer when we are doing our leveling work. So we are saying that for profile leveling, this is the type of leveling that is carried out along a linear stretch, such as a canal, a railway, and a road. Here, we use equal intervals of back sides and then forward sides, such that we can be able to come up with the cross section of such a project. Maybe if it's a road and then you want to construct a road like this one here, so that we can be able to obtain the horizontal distance, and then we can be able to get so we are able to get the horizontal distance along this scale here, and then the vertical height, the elevation along the y-axis. So if we plot such a profile, we are able to identify the nature of ground that you are going to deal with when you are constructing a road. So profile leveling is just carried out to come up with a profile of a construction project that extends in a general line, that extends along a stretch, such as a road, a railway line, or a canal. So in case of a road, we are able to do this leveling, and then we are able to determine where the nature of the ground that you are going to deal with, where we are going to find the rises, then the falls, and then where we need to cut when we are coming up with the formation level of the road. We shall be able to use profile leveling. So profile leveling is performed along a linear stretch in order to come up with the profile of the construction project. Leveling. Now look at this picture here. We have 2 points N and then F. These points are clearly seen. However, we are not able to put the instrument midway these 2 points. So what we do, we use two staffs, and then we put the one here and then the other one here. So we take 2 measurements from each instrument station. When the instrument is here, we take the measurement at this level, this staff here, and then we also take the reading at this staff here. We shift the instrument and then we keep the staffs in position. When you come here, then we are able to take the readings of the staffs. When the instrument is at B, we take the readings at F, and then we are able to take the readings at N here. So if we are not able to establish the instrument in the middle of these 2 points, however near they can be or intervisible, we are going to employ what we call reciprocal leveling. This is employed in case we are leveling across a valley or when we are leveling across a river. So if we are dealing with the river here, we can't put the instrument in the middle here, so we carry out what we call reciprocal leveling. So that is also another approach of determining the difference in elevation between 2 points. So these ones are clearly seen, they are intervisible, but there is no way you can put the instrument in the middle here so that you can take one back side and then one forward side. So we do what we call reciprocal leveling. After doing the survey for the day, like such a survey here, we leveled from A and then to point E. At the end of the survey, we do what we call check leveling. Check leveling, we connect the terminal point to the starting point just to confirm our work. So we are able to do the reverse leveling from the terminal point back to the starting point, so that we confirm our survey of the day. So check leveling is just to check the accuracy of the work that has been done for the day. How is it done? we do differential leveling backwards from the terminal point to the starting point of the work. Look at precise leveling. Precise leveling is just a form of differential leveling which is carried out with high levels of precision, and now we are saying that it is normally carried out by state or national agencies. This is also a form of differential leveling. However, it is carried out with great accuracy and precision. It is carried out using very accurate instruments such that the results obtained can act as references when other surveys are going to be done. So they are used to come up with things like to generate these permanent benchmarks, such that we can reference our leveling work from these benchmarks, which are precisely determined in the precise leveling. We use very accurate instruments, and we do this work, repeat it, like we repeat it very many times such that we get the most correct results that are required for referencing. Thank you for watching. This is my first video, but I promise that we are going to get enough videos about leveling and then other survey work. So stay tuned. And the next video I'm going to post is going to be about reciprocal leveling, how to carry out reciprocal leveling, how to deal with the leveling across a valley or a river. So soon I'll be dropping it, and you should also be able to watch it. Thank you.